Okay, this will be the final lecture on the sociobiological approach segment. And additionally, this is the last piece for week one. So congrats on making it through, almost making it through your first week of lecture materials. And this will be a relatively shorter segment on evolved culture. So the basic idea here is that not only does evolution influence the individual and the behaviors of that individual or the psychological modules of the individual, but it also influences society and culture as a whole. So those environmental constraints lead to selection of certain behavioral repertoires that are seen across and within various cultures. And again, this gets at the nature versus nurture discussion. That's been a big part of this section in terms of these behaviors can be due to environmental constraints that lead to certain, evolved behaviors. However, they can also be taught, as we've seen with those, fear responses or whatever it might be. But examples, sharing and reciprocity can be related to the variance in food resources. And so thinking about this in terms of a natural disaster, it's possible that maybe, let's say, a tornado goes through and wrecks the property of one or two of your neighbors, and they come over to ask for certain resources, certain foods. There will probably be a good chance that you would help out in this scenario and give them, whatever food, resources that might be needed. And in turn, you'd likely expect that if the natural disaster hit your house or your property, the same pro-social behaviors would be given to you when you ask, versus when resources like food are abundant and it's really easy to go get food. Let's say it's cheap too. It's really no problem to get food and be full on a daily basis. Then an individual might be less likely to give their neighbor food, as it comes off as maybe more of a product of laziness or something of that nature. What we'll get into more in the next slide, but what I want to briefly introduce here is life history strategies. So, and this is related to reproductive and resource acquisition behaviors. And so essentially what's going on here is the environment determines cultural survival behaviors and strategies. So not just for each individual person, but as a culture, as an area, even as a whole, these life history strategies will influence how we all act and behave. So I want to talk about the two main life history strategies. Let's talk about the first one. A good example of this would be elephants. So this is where there's a relatively stable environment. Obviously, there are still things like poachers and all that, but compared to other animals, it's relatively stable. Quite a bit of competition though. So then there's a slow life history strategy. So behaviors that you see with a slow life history strategy involve later reproduction. And with this later reproduction, there will be fewer offspring. And with creating fewer offspring, there's more importance, might not be the right word, but let's just say importance with each of these offspring. So you being these elephants will invest a lot of resources into each offspring in hope that this investment will lead to a long-term health of that offspring or those offsprings. On the flip side, there can be dangerous and unpredictable environments, which is um, associated with more of a fast life history strategy. So with this fast life history strategy, the animal that's typically talked about with this is rabbits. And so you'll see sooner reproduction and a lot more offspring. There's, I think, relatively common phrase, mating like rabbits. So yeah, they're known to have reproduction sooner. They're more offspring. And additionally, this might not be rabbits per se, but they'll acquire resources even by unethical means. So an example of that could be fighting for these very limited resources. And more of a short-term health is expected for these dangerous and unpredictable environments. So here, having more offspring definitely makes sense when the likelihood of each offspring living for a long period of time is a lot less relative to those stable environments. So quickly, how this can be interpreted in humans based on this biosocial theory is humans in unpredictable environments. Again, as with animals, you might be more likely here to see that fast life history strategy. So maybe there would be more fast life history strategy in places where that life expectancy is generally lower. And with that, you might expect to see more teen pregnancies across this area, more children in general, or each individual attempting to have more children, actually having more children. Again, with that acquiring resources aspects in areas where there are unpredictable and dangerous environments, you might expect there to be more crime with acquiring these limited resources. And generally, there might just be more of an overall focus on the here and now, which would make more sense in this dangerous and unpredictable environment where putting more of an investment in long-term health doesn't make quite as much sense because it's not as likely of an occurrence. Oops. So the final slide here, actually my advisor and the lab created a game to try and get at this idea of environment and life history strategy. And so basically in this game, you would be a character traveling across an environment, and the traveling across this environment takes energy. And so when using this energy to travel, one must find ways to replenish that energy. And so while traveling, you would occasionally find items. Common items would either be carrots or donuts. And so carrots are low energy, but no risk of obesity, versus donuts, high energy, you get a lot of it really quickly, but there's more of a risk of obesity. And so basically in this game, you want to just continue your survival, which means that you can't completely run out of energy. But if you also eat too many donuts, this can lead to obesity or health related dangers that could also shorten the lifespan in the game as well. So trying to find a balance there. And the key part of the game is that there is for two conditions varied by the amount of resources and length of game. So basically there was a low harshness condition. Basically this is meant to look somewhat like life is here today. in terms of quite a bit of resources, not really having to worry too much about running out of these food resources versus in the high harshness condition, you're not finding nearly as many of these, high energy items. The environment is more unpredictable. And so what was found is looking at this graph on the bottom right. On the bottom, you have donuts eaten, and on the y-axis here, you have survival probability. And so as you can see, in the low harshness condition, it didn't make a whole lot of sense to eat a lot of those donuts, because actually the more donuts you eat when there's so many, when resources are plentiful, the survival probability decreases a little bit, versus in the high harshness condition, whenever you came across a donut, basically you wanted to eat it. As you can see, the more donuts eaten led to vast increases in survival probability, which adaptively, and based on this theory we've been talking about throughout this combined section of lectures, this adaptively makes sense to eat as many donuts when the environment is unpredictable and you don't know when you'll be able to get another high energy food source next, versus in the low harshness condition where you can better predict the environment and there are a lot more of these high energy resources. They can become a problem when you eat too many of these donuts. So that is it. Next, we will be covering more of a neurological viewpoint of motivation. And so continuing along with biological ideas, but just less so that evolutionary part. So we'll be talking about things like neurotransmitters and various brain areas and how they relate to motivation.